Hi, let's get started. And again, thank you, all of you that have been spending this last quiet time in the conference kind of walking through OpenID Foundation work groups. Our chairman of the foundation, Nat Sakimura, is going to be taking you through the financial API work groups effort. Nat?
All right, thanks very much for joining this session late in the afternoon. And why don't you come closer? Let's take advantage of smaller crowd and get some more intensive, interactive session. I've got, how many minutes do I have? 20 minutes. All right, and I've got like 60 slides. So I'm not going to do all of them, I don't think. So, let's make it an interactive thing. Okay, so I saw many people love OAuth security. I went to OAuth workshop yesterday downstairs, and it was full of people, packed. So I thought I would make this session a little bit geekier than what I did on Monday, and talk about challenges of securing OAuth and so on. The requirements are pretty much scattered all over RFC 6749. And some fundamental assumptions are implicit only there. So we need to be pretty aware of what these are. For example, OAuth's primary security assumption is that there's only one authorization server per client. And in case of a personal financial management software and client, it will necessarily have multiple authorization server. And that's the same in many other cases as well. And that means that we have to make sure to have virtual separations, having different redirect endpoints for each server to avoid the authorization server mix-up attack and so on. But in many cases, that's not done and causing a lot of problems. Of course, we could, make everything real secure, using proper options. But at the same time, we also have to consider the specific situation. We have to profile it to, accordingly to the risks that we are exposed to. And what Financial API Working Group is actually working on is on the right top corner of the high security, low environmental control case. Some of the problems that we have to deal with is, for example, is message authentication problems. Communications through user agents are not authenticated, right? We are using TLS, but TLS session is terminated at the browser. And within the browser, it's not protected. So thus, all the message can be tainted there, but often used without any taint check. So neither code nor state can be taken at its face value, but we often do. And we have to think about that as well. And the message source authentication problem is there. Since authorization request and response go through the browser, the receiving ends actually cannot be sure of the real sender. Not only that, what is the server identifier? What is the client identifier in OAuth? We have client ID for OAuth, but that's not globally unique. It's only unique to the server. So if you don't have the server identifier, also known as issuer identifier, and pair with it, it's not good. And because of that, there's a client ID mix-up attack as well. And the message destination authentication problems. The same thing. And then there's a message confidentiality problems as well, right? The browser can actually read everything. And then token phishing and token replace, actually pretty easy. Now what to do with it? these are the kind of problems that we have to address in the profile for financial services, and similarly high risk scenarios. And the FAPI approach is to apply BCM principles to OAuth. BCM principle is something I have named after Basing Clemmer paper. They have worked on some of the cryptographic protocols in ISO to understand what actually is needed for crypto authentication protocols. And I've just picked up those principles there. It's kind of hard to parse, but it's there. And now I'm going to talk about those in the OAuth workshop in Zurich, coming up on July 13th and the 14th. You can go to bit.ly OAuth-WS-2017 about more detail on the workshop. But in the nutshell, what we have to do is clearly indicate what the message is, protocol versions and variant, clearly indicate all the parties involved and their roles in the protocol flow in the message, and integrity protect the message. Those are three main things that we have to do. And in FAPI, we have part 1 and part 2. And part 1 is a read-only security profile. And part 2 is a ReadWrite security profile. Obviously, ReadWrite security profile has higher risk level, so it's going to have more requirements. And in part 1, read-only security profile, we have set up the prescriptive choice of options on RFC 6749 and 6750. For example, require redirect URI to be unique per AS, per authorization server, and require it to be in the authorization request. Now, what does it mean? Redirect URI, actually, when used as the per AS redirect URI, it actually is a good AS identifier. And there is no AS identifier that can be usable apart from that in OAuth protocol. And earlier, I told you that client ID is not globally unique. So to identify client globally, you have to actually couple the authorization server identifier and the client ID. And what I'm doing here is to couple redirect URI as a proxy to authorization server identifier and AS issued client ID. So that's going to be the globally unique client ID. Also, we are requiring unique state value. State value is a proxy to the user agent identifier. So that's the kind of thing we are doing here. And also for the client authentication, we are requiring either JWT authentication or X509 client authentication. Now, since we wanted to be proportionate to the risk, we didn't require message integrity protection for the read-only profile, nor we allow bearer token for resource access. These are addressed in part 2, read-write security profile. So we require everything in part 1, plus message authentication and source authentication. RFC 6749, state of source destination message authentication, is depicted here. If you look at this, you'll realize that OAuth actually doesn't do a good job in authenticating source, destination, and message on the front group. It's almost non-existent. And that's one of the reasons why, and John keeps saying that OAuth is an authentication standard again, right? And in part two, we actually, in part one and part two combined, we actually address everything using request object and hybrid flow. Also, we are actually requiring token binding to the tokens. Bearer token is like, subway ticket. Well, airline boarding pass is just like sender constraint token. It's got the name on it. And, well, actually, it's got the credential information on it. So unless you present it with the credential information, you will not be able to use it. So that's what we have done. And also, we wanted to be very, very prescriptive and lists of things you have to do. So I'm going to show you some of the requirements in the specs as is. For example, for getting tokens, that's corresponding to RFC 6749, we have it something like this. It's, it says authorization. Do you have microphone? Yeah, this would be better. So authorization server shall support confidential client, should support public client. That's nothing, so I've just laid it out. But number 3 is shall provide client secret that adhere to the requirements in section 16.19 of OIDC if a symmetric key is used. Now, we are not talking about OpenID Connect at all here. We are talking about only OAuth, pure OAuth. But OAuth is silent on the symmetric key requirement. So we just decided to use what's written in OIDC. Similarly, for number 4, shall authenticate the confidential client at the token endpoint using one of the following method, right? TLS mutual authentication, or JDivers client assertion using client secret or private key as specified in section 9 of OIDC. And shall require a key size 20,148 bits or larger if RSA algorithms are used for the client authentication, and similarly for the elliptic curve over 160 bits. And shall support RFC 6736, that's OAuth right? With S256 the code challenge method if it supports public client. And shall require redirect URIs to be pre-registered, shall require redirect URI parameter in the authorization request, and so on and so forth. So it's actually a pretty good guidance for you to build authorization server securely. And the requirements goes on and on like that. Similarly, we have requirements for the public client and the confidential clients as well. For public clients, it's got all these requirements. And for confidential client, we've got, in addition to the public client requirements, we have these requirements. And for using tokens, parallel to RFC 6750, that's a pretty good list of things, right? 14 conditions. But to be secure, you actually have to do these. And it's a question of whether you're doing it right now. And for the clients, you have to do these. Some of the things like, conditions after number 3 is actually pretty financial, sector specific, but you still may want to do 1 and 2. And that's only for the OAuth authorization server. Let's skip that. That's only for the, read-only thing. But you could use these for other use cases as well. It's not too much things. And if you're not doing this, you are actually insecure. So I'd actually advise you to do this. Now, for here, read and write, there's going to be much more thing to do. From FAPI Part 2, read and write, we've got these requirements. Notably, one of the biggest differences is that we require request and request URI parameter to be passed as JWS signed JWT as in clause 6 of OIDC, which means that all the requests are integrity protected, even through the user agent. And number 2 is shall require response type values code ID token or code ID token. Now, this means that because ID token acts as the detached signature to the response, your response through user agent is also integrity protected. And if you look at number 4, it says shall include state hash, S hash, in the ID token to protect the state value. So in OpenID Connect, we required C hash, code hash, to be in the ID token, but we are actually requiring S hash, state hash as well, so that the response is completely protected. And since I haven't got too much time, I'll zoom through. And public client has these conditions, and confidential client has these conditions in addition. And protected resource have two conditions as written here, and the client shall support provisions. Okay, that's not too much thing. And then we have defined request object endpoint as well. And there are TLS considerations. We are only allowing these safe ciphers. And if you want to track all these things closely, you can go to OpenID Foundation's Financial API Working Group repository, and all the changes with tickets, issue tickets are tracked there, and you can see how changes are done. So what we expect from now is, since implementers are implementing with the specs now, we'll probably hear back some glitches, and we'll fix those, and we'll go to the final spec, probably by the end of this year. And if you wanted to know if your implementation has actually implemented correctly, we plan to provide the test suite so that you can test against. And if you self-declare that and list it in the public listing, then you'll be OpenID certified as well. So that's a quick presentation from me, and any questions?
Questions for?
Hi, Nat. Do you have any implementation going on, and who is implementing? Are these banks, or are these vendors providing resource servers or authorization servers or clients?
Your question is who's implementing it?
Who is going to who is implementing right now?
So as far as I know, ForgeRock, Ping, maybe IBM, a bunch of because CMA9, the 9 major banks in the United Kingdom, is going to be using it, and they are going to be live January 10th next year. So.
Other questions, comments? Thank you.
Is a little bit more general. So there's a financial profile of OIDC. There's a I think a healthcare one, an iGov one. I'm just curious what the Venn is between all these that are requiring each vertical to go off and profile it on their own, or there are vast differences?
Could you speak it louder because
I'm sorry. So I was asking, there are a number of different profiles now emerging. There's a financial profile, there's a, I believe, a healthcare profile, a government profile. So it seems like each vertical is profiling on their own. I'm curious, how much of a overlap, what the Venn looks like between them, how much overlap is there? Why is each vertical requiring their own profile, and is there ever any possibility of getting to a common profile, maybe based on assurance levels rather than each vertical?
Well, so we're kind of starting off to address each vertical's needs, right? And as we have worked on the FAPI for a year now, we found out that maybe FAPI profile can actually be used in other places as well. It's more of the general higher assurance profiles, and we are starting to talk with Moderna working group, and iGov probably as well. Any technical questions?
Hearing none.
All
Thank you,
right.
Nat.